Today I'll be talking about hierarchical clustering. This method is a clustering technique that allows you to group similar points together. So this method is particularly useful if you want to identify particular subgroups within a group of points, and it'll allow you to attain a granularity that you need. Specifically, I'll be talking about the agglomerative hierarchical clustering method, which is a bottom-up approach, which allows you to build clusters from the bottom up as you go up the hierarchy. So first, we start with 5 points from A to E on this graph, and then I'll go through the algorithm and explain the clustering process through this diagram. So first, we want to assign each point to its own cluster. So we want to draw a cluster around each point here. And now we enter this while loop, which keeps on repeating until all points belong to one single cluster. But then in this case, that's not true. So we go into the while loop, and we first compute the center of each cluster. Since each cluster only contains one point, its center is the location of each point then. So we're done here, and then we've now combined the two clusters with the nearest centers. So as you can see here, we'll be using Euclidean distance to calculate the distances between the clusters. And in this case, we can see that between D and E, that is the smallest distance between all combinations of the clusters. So we will draw a cluster around here to combine D and E, and then we repeat the process and go back up to the while loop again. So now we compute the center of each cluster. A, B, and C, we already computed the center since it's the location of the points themselves, but then this new cluster, we need to calculate the center, its center. So between D and E, we just use the average x and y location of both of the points. So that would be around here, which is 4.25 and 2. Now we have all the centers. We want to combine the two clusters with the nearest centers once again. So we have 4 clusters at the moment, so 1, 2, 3, 4. And then we want to look at which 2 clusters are the closest distance. So in this case right now, it's between A and B, which is of a length of 1. So we combine them together. And then now we repeat the process. Now we only have 3 clusters to work with, but then we want to compute the center of each cluster. Since these are both calculated already, but we need to calculate this one. So between A and B, the center would be here, which is at 1.5 and 1. So now we completed all the centers, and then now we have to combine the 2 clusters with the nearest centers, which in this case will be between the cluster that contains A and B and the cluster that contains C. So we want to draw a cluster around here to combine the 3. And now we repeat the process once more, and then we have to compute the center of this new cluster, which is around 1.5 and 2. And since we only have 2 clusters remaining, that means that that's what we have left. So we have to combine the 2 regardless. So this is the final cluster here. And then since there's all of the points in here belong to one cluster, the while loop exits, and then we're done. So the hierarchical clustering, we can represent it in a dendrogram, which is represented as a tree, which shows you the hierarchical groupings of the algorithm itself. So first, we want to start at the lowest level, which is A and B, as well as D and E. So we'll draw the leaves of the tree first at the lowest level. And then first we combine the 2 because these points are clustered together. And then as you go a level up, you can see that C is being combined with the cluster that contains A and B. So we have C that comes in later. And then finally, we have the overarching cluster that contains all the points, which is this particular cluster here. So we combine them in the end here, down here. So as you can see here, this is the dendrogram that will represent this hierarchical grouping here. And for completeness, I'll also tell you the runtimes of the algorithm itself. So the algorithm itself will be of big O of n cubed time complexity, and the spatial complexity is a big O